Greetings everyone! Before you get started with this video, let's do a quick review of solving for x when it's in the exponent. Recently we discussed how to solve using common bases. So let's review that. For my first example here, I want my base to be the same. So I can use my perfect roots chart. I can think of what these would divide down into, and in this case, I know they could both have a common base of 2. 2 squared would get me to 4, and 2 cubed would get me to 8. Then I would bring down the initial exponent. Once I have those common bases, it's kind of like I drop those 2's and I set the exponents equal to each other. And then I can solve for x. Now let's take a look at this next example. I have a base of 4 and 24. Take a look at your perfect roots chart or think about this. Can 4 multiplied by itself get to 24? Nope. Can 2 multiplied by itself get me to 24? No. So I keep hitting a wall where I don't have a common base. So what do I do if I still need to solve for x? That's where logarithms come in. So if you do not have a common base, you're going to use logs. For this lesson, you're going to want your notes foldable that was provided. Your perfect roots chart would be helpful, and you definitely need a calculator. On our notes foldable for logarithms, let's fill in the following and get started. First of all, the format of a log looks like this. We have log with a little sub base b. So make sure that you write it a little bit lower, a little bit smaller, of a and then equals x. So how I would read that, this is if I was going to read that equation, I would say log base b of a is x. So I can read you a question by using that phrasing. So the overall arching question that we're trying to answer today is what exponent's required to go from a base of b to reach a value of a. So make sure you jot that down on your note sheet. What exponent is required to go from a base to b to reach a value of a? Now, out of all of this, to be honest, this next piece of information is really the money shot here. This is what you're going to want to highlight, put a star by. This is your conversions. So how do I go from the exponential form on the first slide that I didn't know how to solve? And how do I convert it into a log so I can solve? So let's take a look. Exponential form is something you already know. I know that in exponential form, I have a base with an exponent and it equals some value. We've been writing exponents like this since probably pre-algebra. But how do I convert it so I can actually solve? So why would I need to do that? Well, let me give you an example. If I had 2 to the x value and it was equal to 3, there is no value that I know of that could get me from 2 to 3, no exponent value. 2 to the 0 would be 1, 2 to the 1 is 2, 2 squared is 4. So it's got to be some irrational decimal value that would get me there. So that's where logarithms come in. I'm going to convert it. To convert, we start with the log. The base becomes the base. The exponent becomes the answer. My answer becomes my main value. So if I was to convert this question that I'm starting with, I would start by writing the word log. The base becomes the base. The exponent becomes the answer. And what's left over becomes my main value. So now you can see I've isolated the x as the answer. So now log base 2 of 3, we can solve that. We can use our calculator to find that exact value. One of the ways that I always remember this conversion, whether you're going from exponential to log or log to exponential, is I use this phrasing. I always say base to base. We always go back and forth between the base under the exponent and the base of the log. The exponent converts with the answer. So the exponent becomes the answer, or the answer becomes the exponent, back and forth depending on which way you're converting. The third, or in this case the 3, the value that I have, sort of falls into place after that. It just makes sense where it should be. So really, I always say the base becomes the base, the exponent becomes the answer, and then I fill in the rest. If you're looking for other clever ways to remember this conversion, check out YouTube. There's lots of little videos, songs that people have made. If you're good at memorizing, maybe your best shot is to jot down an example like this on the top of a worksheet, homework, any notes, just to make sure that you have that available all the time. Now, if you open your notes, we're going to convert and calculate these logarithmic expressions and equations. So first of all, if I'm going to use my calculator to calculate these logarithms, you need to know how to type it into your calculator. So in that little box there, we're going to fill in how do we plug that into our calculator. So I apologize, it's a little bit small, but it says log base A of B is equal to log of B over log of A. So we do this because if you were to type the word log, your calculator doesn't give you a spot for the little base, for the sub value there. So we have to do a conversion to actually get the calculator to get what we want. So let's explore what I mean by this. On some of these problems, we're going to convert and we're going to check using our calculator. So first of all, I'm going to convert. Technically, this isn't equal to anything, so I'm just going to say equals to an unknown. It's equal to x for right now. So my base becomes my base. My answer becomes my exponent. What's remaining becomes my answer. So if I take a look at this, I can use my chart to figure out what x equals. And in this case, it would be cubed. 4 cubed gets me to 64. So if I wanted to check in my calculator, I would have to type in log. It'll probably bring up a parenthesis. Your B value, your top value is how I always look at it. The top goes on top, the bottom on bottom. So I have log of 64, close that parenthesis, divide it by log, it'll open a parenthesis, and put the bottom value, your base, your A, which is 4. When you plug that in your calculator, you would also get 3. I'm going to ask you to do both. You're going to have to use your calculator for some because you're going to get an irrational value, and you're going to have to convert for some because there's going to be all letters or symbols. So you have to know both pathways. Let's take a look at another one. Log base 4 of 16. If I convert first, the base becomes the base, the answer becomes the exponent, therefore what's remaining becomes my answer. So that's a pretty easy one to look at. I know I'm going to have x equals 2. So if I wanted to check in my calculator, I would say log of 16 divided by log of 4. And I would get the same answer of 2. All right, for the rest of these, I'm going to go through the converting process because I honestly feel like that's a little bit faster since we've been working with our exponents so often. So let's take a look. The base becomes the base. The answer becomes the exponent. What's remaining becomes the answer. So 5 to the what gets me to 125, in this case, 3. All right, let's take a look at the next one. The base becomes the base. The answer becomes the exponent. What's remaining becomes my answer. Uh-oh, take a look at this one. So I went from a big number to a small number. Well, let's compare the 7 and the 343. I know I can get from 7 to 343 by using an exponent of 3, but I'm going big to small. So if I cubed rooted 343, that would be a 7. So cubed root is the same as 1/3. So my exponent is 1/3. Let's take a look at another reason why that is. If I had 343 to the 1/3 and I converted it to radical form, that would be the cubed root of 343. So that 1/3, E over I, remember that, is how I get to that value. So anytime you go big to small, you should have a fraction. All right, let's take a look at the next one. The base becomes the base. The answer becomes the exponent. What's remaining becomes my answer. Oh, again, I went big to small. So I have to take a look. First of all, how can I get from 4 to 64? In that case, it's 3 again. But I went big to small, so it should be 1/3. The cubed root of 64 is 4. All right, let's take a look at this column. The base becomes the base. The answer becomes the exponent. What's remaining becomes my answer. So 6 to the what gets me to 216. And in this case, x equals 3 again. The base becomes the base. The answer becomes the exponent. Therefore, what's remaining is my answer. Okay, I can get from 3 to 243, but it's 1/. So I took that 3 really and I kicked it to the bottom. If I'm kicking it to the bottom, what kind of exponent should I have? A negative. So make sure that if you end up with a whole number equaling a fraction, that you should have a negative exponent. And in this case, a -5 specifically. All right, let's take a look at the next one. The base becomes the base. The answer becomes the exponent. What's remaining becomes my answer. And that's a quick one, 2 squared. The base becomes the base. The answer becomes the exponent. What's remaining becomes my answer. This one should be on our chart. In this case, if I do 2 to the 4th. All right, let's take a look at this one. If I have the base becomes the base, the answer becomes the exponent, what's remaining becomes my answer. It got kicked to the bottom, so therefore I know I should have a negative exponent, and I'm going from 6 to 216. So in that case, I can use my chart to see that it would be a 3. Well, wait a second. Look at these two questions. Look how similar they are. We have the same base. We have the same large number. The difference was it was kicked to the bottom. So we had a 3 versus a -3. So all of these, yes, you can check all of these on the calculator. You could solve all of these on the calculator. And I'm fine with that on homework or on a quiz. But now on the right side of our notes, you'll notice we have 2 variables. So here's how I can check if you understand the conversion without the calculator. So I'm going to convert these. I'm not solving, I'm just converting. So I'm going to start with converting from exponential to log. The base becomes the base. The exponent becomes the answer. Therefore, the answer becomes my main value. The base becomes the base. The exponent becomes the answer. Therefore, what's remaining gets filled in. The base becomes the base. The exponent becomes the answer. Therefore, the x is your main value. The base becomes the base. The exponent becomes the answer. Therefore, what's remaining becomes your main value. The base becomes the base. The exponent becomes the answer. What's remaining becomes your main value. The base becomes the base. The exponent becomes the answer. Therefore, what's remaining gets filled in as your main value. So notice, if you just keep repeating yourself over and over, that conversion is going to be easier to remember every time. Let's take a look at the right side. Now I'm going log to exponential. The base becomes the base. The answer becomes the exponent. What's remaining becomes your answer. The base becomes the base. The answer becomes your exponent. What's remaining becomes your answer. Now make sure that if you have a fraction that you put it in parentheses because all of that fraction is to the y value. The base becomes the base. The answer becomes your exponent. What's remaining becomes your answer. Base becomes the base. Answer becomes your exponent. What's remaining becomes your answer. Base is your base. Answer is your exponent. Base is your base. Answer is your exponent. So again, just keep that repetition. Or if you need to find some little song or ditty online to help you remember, make sure you do that. How about this? What if I asked you to solve log of 100? Well, the first thing we'll notice is I don't know what this is. I don't know what my base is. So I have to do a little bit of work here. When you don't have a base written there, it's what we call a common log. So you probably don't have a spot for this in your notes foldable, so just add it somewhere around your notes. So when we don't have a base, it's assumed that the base is 10. So we call that a common log. Okay? So if there's no base present in the log expression, we can assume the base is 10. Log base 10 is referred to as a common log. Now, also what you need to know about common log, that's what your calculator does. Okay? Is if you type in just log and then a number, it automatically does that base 10. So for example, if I was to type in log of 50 into my calculator, it's actually typing in for me log base 10 of 50. So because our original question here would be a common log of 10, you could just type that in. Now I could also convert. The base becomes the base, the answer becomes the exponent, what's remaining becomes my answer. So I know I should get 2. So if you type in log of 100 in your calculator, you should get 2. So what's most important, if there's no base present, assume the base is 10. All right, make that assumption and then use the same rules that we used all along. So make sure that you have all of your notes filled in. We definitely have a worksheet or some kind of practice, so check Google Classroom for that. Let me know if you need any extra help. But the key thing is that conversion. So make sure you remember that that base becomes a base and that exponent is part of your answer. So convert back and forth, and then that third value will fall into place. We'll see you next time.